Learn some key tips and tricks when you're thinking about moving to Azure SQL, especially related to SQL VM sizing. This week on Data Exposed MVP Edition. Hi, I'm Anna Hoffman, and welcome to this episode of Data Exposed MVP Edition. Today, we're joined by MVP member Tim Radney. Tim, thanks so much for joining us today. Can you tell us a little bit about what you do?
Sure. I am a principal consultant. I've been working with SQL Server since version 6.5, but pretty much full-time SQL Server DBA since the 2008 timeframe, working with Fortune 100 customers down to the mom and pop selling sheet music out of their basement. So I love SQL Server and all size workloads and helping customers get the most bang for the buck.
Awesome. It's great to have you on the show. And Tim and I, we've been crossing paths at a lot of events, virtually and in person when that was more of a thing. So it's great to finally get you on the show. And, I know, Tim, you've dealt with a lot of customers and helped a lot of customers actually move their environments to Azure SQL. I'd love to get your key points of advice when it comes to migrating to Azure SQL, especially Azure SQL running in virtual machines.
Oh, absolutely. So Azure SQL, it's a fantastic place to move your workloads. You have so many options from SQL Server on Azure VMs to the platform as a service offerings with your Azure SQL database, your SQL managed instance. So pretty much any workload can find a home. But I wish I could get in front of more customers before they start moving workloads and migrating and be able to help them understand kind of the differences between the environments. Because on premises, you have infrastructure. You go buy these large storage arrays, you provision the disk, you can add more cores, more memory. In SQL Server or Azure, you can still add more compute, but it's kind of different. One of the main things I wish customers understood is looking at their disk. Typically, we're monitoring our storage based on read-write latency. Those are the metrics we're looking to see how fast or how slow the disk is, not so much how much storage we're picking up or putting on disk. So your throughput, your megabits per second read and write. And when we start looking at the Azure space, we have some limitations based upon the size of your environment. So where customers are going and looking for the virtual machine, it's pretty simple. You have number of cores they need, the amount of memory they need, the amount of storage capacity they need, and we're going to go fast with premium disk. And they go size that, not realizing that there's limitations for your cached and uncached throughput. And that's usually where I see customers hitting kind of the wall, the performance hit is on that throughput, the limitation of the size of the virtual machine. And it's pretty easy to capture that, but you have to know that you need to capture it in order to size that VM.
Awesome. And so what are some tips around capturing that or checking, what is needed for my workload?
All right. I love that question. So what I've put together for a lot of my customers is just I call it the poor person's monitoring. So the data that you need is pretty much already there. There's DMVs that are capturing your CPU. You can capture page life expectancy. So you can get those things for your normal metrics. But from the disk, we have this wonderful DMV, the SysDMIO virtual file stats. You can also use perfmon. You can use other third-party tools. And a lot of my customers have had third-party tools that are capturing the bytes written per second and read per second, but you have to do the math of what is the interval between those data captures. Is it a second? Is it a minute, 5 minutes? So I capture on a 5-minute interval, and then I do the math. I divide the number of bytes written based upon the number of seconds that I did the capture. So 5 minutes, 60 seconds, I do the math, and now I'm do a little bit more conversion to get from your bytes to megabytes, and I'm able to see how much megabytes per second or read or write have occurred, so that we have a better understanding of what their workload is picking up and putting down on the disk. So perfmon, the DMV is already there. You can persist that to a table. That's pretty much what I do. I just send a data collection package. They run it, let it run for a few weeks, and then it's just querying that data. And I've actually got an example I can show.
Oh yeah, let's take a look.
All right, so pretty well straightforward. This particular table, I usually just call it file stats. This was a primary node for a customer, and I sanitize the database names and things. But if I query just based on megabytes per second read and descending, then I can come through and see like DB 20, 12, and 20, so the top ones. Notice the read latency in milliseconds, write latency in milliseconds. So we see some 7s, some 9s. The write is very low, but those are still pretty solid, good numbers. Anything sub 10 milliseconds is pretty good for looking at read and write latency. But if I scroll over, we can see the megabytes per second read, 3419, 3400, 3210. But notice the capture date. It's pretty consistent across the different days. It's usually always in the 9 to 910, 925 timeframe. So I would go back to this customer and ask, hey, what is going on at this time? And I can pretty much guarantee you right now, this is going to be when their full backup kicks off. So we're reading everything from disk, we're writing that. I expect that. In an Azure VM, if I'm doing my own SQL native backups to another piece of storage, do I care if the backup took an extra 10 minutes or 15 minutes? Probably not. So if I scroll down and look at some of these other time frames, we can see that now we're starting to see 11 o'clock, 10:30, different time slices outside of that early 9 o'clock. Mm-hmm. So we're getting into probably more business time frame when customers are accessing the system. So these are some legitimate numbers of 1,500 megabytes per second. And if I look back over, notice DB10, DB6. So it's primarily 10, but there is a 6. So those would be combined if they're the same time slice. So we have the raw data. So now I can go through and look at, okay, this time frame, what is my total megabytes per second read for this instance? And are we moving the entire instance to the Azure VM so I can get a better understanding of how much disk throughput that we need? Now, a trick with that is then going and sizing the virtual machine. So the VMs have what we call the max uncached disk throughput in your uncached disk throughput. And some of these VMs, we can see the size. Let me scroll down so I can move back over. So we see the name of the virtual machine. So we see some of these, a 32 core, a 16 core, but looking at your max uncached, and you see the IOPS and then megabits or megabytes per second. So 250, 500, those are fairly low from the data set that we just looked at with some 3,500s, some 1,500s, even though we see max number of disk. So 32 data disk, I can put a lot of P30 disk that support 200 megabits of throughput. But if the VM is capping me at 500, my storage capability will surpass what the VM will allow. And this is where a lot of customers get into a performance issue, is they're very IO intensive of reading and writing to disk. Now, the customer I just showed, they are exceptional. That's a very large data set. They're moving lots and lots of data, but they would probably fall into more of a 1,000 megabits per second machine, but now that's 64 cores. That's a lot of SQL Server cores, but we're so thankful that we have this thing called constrained cores. So we can actually get, if this VM needs 16, we can get the M64-16. So we're only paying or licensing 16 cores of SQL Server, but we're paying for the compute of 64. So that's where we really get into having to size proper and not pay a large SQL Server license fee just to be able to have higher compute levels. Now, I have a lot of customers like, I don't understand what the VM naming standard. Well, it's very well documented. And so you can come and take a look. So your M, that's going to be your the memory optimized. So you have your number of cores and then the breakdown of all the acronyms. So your A would be your AMD processor. Things that we're really looking for is S for your premium storage. And then D for the local temp disk. So that's where you can put temp DB.
Hmm.
But the biggest thing that I wish customers got was we need to establish that baseline of how much you're moving back and forth off the disk. And writes are just as important because you have this whole write, T-log write limitation, your write throughput, how much you can put down on disk. All of these numbers, though, since I've been working in the Azure space for several years now, keep increasing. So we get more throughput, including Azure SQL database in your managed instance. Just last year, there was a big uptick in the write throughput for your SQL MI. So these numbers are getting better. There's more and more virtual machines that are coming out that have different computes. So your faster CPU core speeds versus your standard VM sizes. So there's been a lot of improvements. And I've yet to come across a customer that once we size the server, that they're like, whoa, that's way too expensive.
Right.
I mean, especially with the constrained cores, because the SQL Server license is a big part of that cost. And when you're looking at some of these machines, it's, to get from 500 to 1,000 megabits per second, we're increasing $800 or $1,000 a month for the compute. They're like, that's 12 grand a year. This is our business critical system that's making us tens of millions of dollars. That's a drop in the bucket.
Right.
So it's truly, if people could get that, I would do a lot less business because they wouldn't need me to come in and optimize if they would just get that right the first time.
Got it. This is really useful, Tim. So, let's say we figure out baselining, we figure out the sizing. The next thing is like going to either pick kind of one of those pre-configured gallery images of SQL Server in an Azure VM, or going and deploying a VM and then downloading and installing SQL Server yourself. What's your recommendation on that front?
Right. So typically, I previously would have said it's better to spin up the compute and install SQL yourself and configure, because the gallery images were still putting the system databases outside of TempDB, would put master model MSDB on the C drive, didn't give you hardly any customization when you're deploying the machine for like max stop and cost threshold and min-max server memory values, some of those things that were always changing. And just recently, I believe there was a data exposed session with Pam and several others that kind of went through and introduced a new and improved SQL and Azure VM deployment that they've come up with that gives a lot more of those customizations. And so I deployed a VM last night just to go check this out. And in that virtual machine, when I deployed it, and we'll step through real quick, it prompted me, hey, do you want to put your system databases where the user databases, which would be the F drive? I'm like, yes. TempDB, it prompted me to set the initial size and the auto growth and all of those things. One challenge is SQL Server agent still is not enabled by default, or you start by default. And so I get the legacy there. The struggle I still have, though, and this was the big pet peeve, was this installs everything. So if you look at services, we see SQL Server, so MS SQL Server, but we also have analysis services. We have integration services. Thankfully, reporting services has been removed from the ISO. You have to install that separately. But these are services that are also installed and running that are consuming a little bit of memory. Not a whole lot, but anytime I patch SQL Server, I also have to patch analysis services, integration services. So unless my customer needs it, this is additional products that are running that increase the surface area configuration. But now the way that Azure VMs are deployed, you have the IaaS agent, so you can have a pay-as-you-go, you can have automated patching, you can have the Azure as backup. I mean, all these things that are integrated already, plus the caching options for your disk are set with the gallery images. So for a lot of customers now, I would say if they're going to deploy, use the gallery images, and we can just go and install these few things. And your VM is in a better place, rather than you go provision just to compute and it's not SQL optimized with the IaaS agent and all these other best practices. The tables have turned. Now, if I'm doing it, I know what I'm doing to set the caching for your data disk and not your log and configure. But tempdb, if we look real quick, tempdb is on the ephemeral disk, which we know when you restart SQL Server that that disk is pretty much wiped. But it's deployed by Azure, and so it will recreate tempdb on this disk. I don't have to put any hokey process in place to create the tempdb folder so that tempdb can be created when SQL Server service is starting. So it just makes it so much easier if you now leverage the gallery image and then go still do a little bit more tweaking, but it's less time for me to just go uninstall integration services and analysis services than to go and right size everything else. So they've done a phenomenal job. But one last thing I want to show is when you go into Azure and I say I want to create a resource and I want, let's just say SQL Server. Let's say 2019. So SQL Server 2019 on Windows Server 2022, we'll pick, let's see. All right, I'll click Create. So from here, we come down, it's the free SQL Server license. So this is going to be a developer edition, but I can click on all sizes. So this is where you would come in and start choosing your virtual machine. And notice there's 507 sizes. That's a lot, right? But we know from our SQL Server workload that we can narrow things down. I don't need all CPUs. I'm on 16 vCore, and I'm not going to use up to 416. It's going to be 16. That's what I'm going to license for SQL Server. And for RAM, I have 100 gig or 112, 118, whatever your system is, and our page life expectancy is right where it should be. I can't go any less. I would love to go more, but I know I don't want any less than 100. And let's add some more filters. So we want to premium disk. We're only going to run premium disk on production SQL Server. And we also want that ephemeral disk support so we can put tempdb there. So as I do that, notice it still is grouping by VM size. Change your group by series to no grouping. And we see we're now down to 24 options out of the 507. And mostly we're in that memory optimized because it's a larger memory footprint. And we can see a lot of these are E32-16. So that's a 32 core compute node, but only 16 made available. So you're only going to have that 16 on SQL Server license, similar to E64. But look at some of these prices going from the E32 to the E64. Yeah, it doubles. But looking at the overall cost that you're getting for the storage, your infrastructure, I mean, all of those things, it's really not bad when you look at total cost of ownership. But this, I mean, that's like the key thing, just leveraging those existing filters to put in what you know, and then come through here and you can start looking at some of these sizes and then toggling back over, finding that to see what your throughput limits are. It's
awesome.
It's really that simple. But if you don't know to go look for these things, I mean, who would have known to be looking at throughput limits that I can provision, terabytes of disk that have hundreds of megabits of throughput capability, but your VM size is going to limit that.
Awesome. And, well, thanks so much, Tim. This has been really, really useful. I learned a lot, and I'm sure our viewers have learned a lot. We're going to put a couple links in the description. Do you have any final tips or tricks that you would advise folks as they get started here?
Just baseline, know what your workload is. Don't look at just running benchmarks, seeing what your infrastructure is capable of. I've seen customers do that, and then they go to try to size that in Azure, and I'm like, you're trying to provision $1 million SAN to a single VM. Don't do that. Look at what you're consuming, not just what's been provisioned. And I've had customers go the other way where they over provisioned on premises, and we don't need a half a terabyte of RAM. We don't need 32 vCores. Their max throughput outside of database backups is like 10 megabits per second, right? I mean, so until you capture that, you're really throwing darts, and don't do that.
Awesome. No, that's great advice, and really enjoyed having you on the show, and hope to see you in person sometime soon. To our viewers, if you like this episode, go ahead, give it a like, leave us a comment, and let us know how you're using SQL Server on Azure virtual machines and sizing and all that good stuff. And we hope to see you next time on Data Exposed.